Hey guys, so here's the hand, the animatronic hand that I've made for Deakin University Microcontroller Principles unit. As you can see, it's a freestanding sealed unit, no wires hanging out or anything like that. It's a beautiful masterpiece. So first of all, design and construction. Anything that you can see that's yellow is my design. I've designed it all in SolidWorks myself. And that includes the insides of it. So if I just open the back up, you can see inside there, got the servo assembly, some power supplies and such. So yeah, everything that you can see there is my design, done in SolidWorks. Just quickly show you the few of the SolidWorks models I put together. So that's my servo assembly that's inside. As you can see, they fit together very tightly because I was a little bit constrained with space. I designed my enclosure a little early because it was a 50-hour print all up. So I needed to get that done early in case there was any problems and I had to start again 45 hours into the print or something. Just with the servos here, they're not my design, they're a GrabCAD user's design. I just borrowed them to use for the to save time on putting the assembly together. And here's the hand, you can see them side by side. That's what I designed the hand, put the assembly together to see what it looked like before I printed it. I thought it looked pretty good, so then I went ahead and printed it on the 3D printer here. The actual operation of the arm works by the servos inside the enclosure pulling on this fishing line. As they pull it down, and each finger will curl. When I first put the arm together, the fingers weren't really curling, they were coming down like that, which isn't really good when you want to do sign language characters because most of them need the fingers to bend. So what I've done is I actually, at the beginning, designed all the fingers with, there's actually tubes running, 2 tubes in each finger running through each phalanx, and they've got little exit holes here as well as you can see through the back there probably. Just bring it a little bit closer so you can see the elastic running through each finger. So what I've done, I've created a tension differential between each phalanx so that the tension's greatest on the first phalanx and lowest on the last. So when the cord's pulled, the first and second phalanxes tend to curl up first because there's less tension in them. When they reach the limits of their movement, then the third phalanx curls. So I've just put these little tensioners on the back here with a little bit of raw 3D filament to hold the elastic, and pulled the elastic through with pliers to create that tension differential. You can see the servos working inside here, pulling the fishing line down through the internals of it. Yeah, so let's have a look and see what it can do. I'll just switch it on through the switch hole in the back here, and then you'll see it do the startup sequence. Okay, that means we're ready for action. So let's go through the American Sign Language characters. I've got to do 5 American Sign Language characters with the hand through this user interface here, which is just a little 3x4 matrix keypad. So the first letter is A, so I'll just press 1 for A. Now we'll do it slowly. just select fast mode again for the next character, which is C. So that's on button 2. We'll go to C quickly, and we'll go slowly to C. Select fast mode again for the third one, which is I. Let's go there, do I slowly. Nice and slow. And then we'll go back to fast mode for the fourth one, which is Y. It's like a hang loose sign if you're a surfer. Hang loose, brother. And we'll go slow to that one. Okay, I'll select fast mode for the last one, which is S on button 5, straight down to S. And then we'll go there for slow. Got the thumb to come around last so it doesn't interfere. Beautiful. And now, hopefully, if I press 0, it'll do the startup sequence again for test purposes. There we go. Beautiful. No wires. Standalone unit. Even though we're using an Arduino board, we're not actually using Arduino high-level functions at all. It's all programmed in C with only ADR high-level functions being used because that's the chipset family that we're using. So use of interrupts, the main interrupt on this one is the ADC interrupt, which updates the ADC storage variable on each reading, and that comes from the LDR here, which I'll explain a bit more in the X Factor section. Program overview, so it's, there's switch case, which I think most people probably used with the 3x4 or 4x4 keypad matrix keypad. So it's controlled by what button you press, then selects the appropriate program for whatever ASL character or whatever we run for each button. I guess what I focused on, I spent a bit of time on with the program, was getting the natural hand movement, so each finger to move at the same time rather than one at a time. I don't even know if I can do it, but one at a time, which is the easiest way to program it. Instead I used a while loop with nested if statements within each one, just to get them to move, each finger to move to its own spot incrementally at once. So that's the main thing I focused on with the program, I guess. Budget, so the budget came to $42.57, around about. And the most expensive items were the servos inside, around $14 I think for the 5 servos, not the Tower Pro SG90s, 9 gram micro servos. And then the 3D plastic, that was about, I think it was about $12 worth of 3D plastic. 3D printed plastic. That's with a student discount applied. Hey guys, just showing you my X Factor on the hand. So to you guys at home who are playing along, don't know what we're talking about by X Factor, it's just a adding our own components after we've met the design criteria of doing sign language with the hand. So I've added a RGB LED here, which I'm doing a little bit of colour mixing with PWM, and LDR on the middle finger there, light dependent resistor. Got the cables running up from the internals here through the hand, through the fingers, with a little bit of slack cable there to enable finger movement. And yeah, let's see if we can see it in action. I might turn the light out here. First of all, I'll just chuck this cloth over the top. Goes to sleep. A little bit of light getting in under the cloth there, bouncing it around a little bit. Take the cloth off. It's not the weight of the cloth, I can assure you. Bouncing around there with the light. I'll turn the light out. There we go. Oop, he's grabbed onto the cloth, I can't get it out. There we go, he's let go now. Turn the light out again for one more go. One more. It's kind of fun. Beautiful, hope you liked the hand. Thanks for watching the video, guys. Really appreciate it.